Hello students, welcome to the lecture sessions of Mathematics 2. Now, in today's session, we are going to start with a chapter series solution of linear differential equation. Basically, we are solving the linear ordinary differential equation. Now, here we are using the word series solution. Now, first of all, we are going to define what is a power series. Correct? So, a power series in the power of x minus x0 has a form sigma Cn x minus x0 raised to n, where n is running from 0 to infinity. Or if you are writing it in a simple form, then it is C0 plus C1 into x minus x0 plus C2 into x minus x0 whole square plus so on. Such a series is said to be a power series centered at x0. Okay. Now, the simple power series you have learned in semester 1. Here, x0 is the center, correct? And C0, C1, C2 up to C0, C1, C2 up to Cn and so on are coefficients of a power series, correct? Now, here I have written one note. The power series sigma Cn into x minus x0 raised to n holds one of the following conditions for convergence. The series converges at a point only x is equal to x0. That means, suppose you have radius of convergence r is equal to 0. Then in that case, if you are going to put x is equal to x0, then you will get only first term c0. And that means it is finite and limit will be unique for x equal to x0. Correct? So in that case, it is converges for only and only point x is equal to x0. Vice versa, if you have r is infinite, then in that case, the series converges for all points x is equal to x0. So we are discussing about point x0 and r is a radius. So if you are taking infinite radius, then from point x0 in the both direction we have infinite radius. So all the points on real line are in interval of convergence, and in that case your series is going to be convergent for all of them. But suppose r has some positive real integers value. It is not necessary that it is integer. It may happen it has any real value. Then in that case also series is going to be convergent for x minus x0 less than r. That means you have a interval of convergence from x0 minus r to x0 plus r. At end point you have to discuss. Okay. And for greater than r, that means mod of x minus x0 greater than r, then series is said to be divergent. Here capital R is nothing but that is your radius of convergence. Okay, now radius of convergence you have learned in the first sem, and the formula is, if you have to obtain the radius of convergence, then it is obtained by mod Cn upon Cn plus 1 by ratio test, correct? So this is the radius of convergence. Now, classification of singularities. Now, before going on to the singularities, we are defining the second order homogeneous linear ordinary differential equation with variable coefficients. Now, see, here we have written the second order differential equation. P0x plus d square y by dx square plus P1x into dy by dx plus P2x into y is equal to 0. This is the equation number 1, where P0, P1 and P2 are polynomials of x. It is not necessary that they are only polynomial, they are any functions of x. Considering that P0x is not equal to 0, then the equation 1 can be written in the form of d square y by dx square plus px into dy by dx plus qxy is equal to 0. Correct? Then in that case, this px is nothing but it is p1 upon p0x. Same manner qx is nothing but p2x upon p0x. That means you are simply dividing equation 1 by p0x if it is not equal to 0. So this equation number 2 is a standard form of second order linear homogeneous equation. Okay. Now here using this px and qx, we are going to classify the points. First we are defining the ordinary point. Now ordinary point, a point x is equal to x0 is said to be an ordinary point if px and qx are analytic at x equal to x0. Now analytic, that means basically you have the Taylor series expansion of both functions at a point x is equal to x0. But this process will going to be very lengthy. So in another word, what we are going to do, we are using simple notation p0 x0. That means x equal to x0, if you are going to put in p0 and this value is non-zero, then whatever the point x0 we have, it is said to be an ordinary point. Okay, correct? In other words, whatever the denominator of px, if it is non-zero at a point x0, then that point is called ordinary point. Vice versa, a point x0 is called singular if it is not ordinary. That means if the value of denominator is 0 at a point x0, then the point x0 is called a singular point. I am writing very simple example. Suppose I am writing p of x is equal to x upon x minus 1. Okay. So this px is not analytic at x is equal to 1. Why? Because denominator is 0 at x is equal to 1. So x equal to 1 is going to be a singular point. But if you are taking any point other than 1, if you are going to take any point other than 1, then they all are going to be ordinary, because in that case denominator is not going to be a 0, and if denominator is not going to be a 0, then that point is called ordinary point. This is the simple concept of ordinary and singular point. Okay. So wherever the denominator is 0, that points are singular, and other than that all points are going to be ordinary. Now types of singularity. So if you have a singular point, then it is dividing into two parts. Either it is a regular singular point or it is an irregular singular point. Now see, a point is said to be a regular singular point if, first of all, the singular point is said to be a regular singular. That means whatever the point x0 you are going to take, it must be a singular point. Then only you are going to define whether it is regular singular or irregular singular. And it is of equation 2. Equation 2 is your standard equation y double dash plus px y dash plus qxy is equal to 0. Okay. So if we are going to put this value in this px and qx, then px and qx are not defined at x0. That means that is a singular point. But that singular point is said to be a regular singular if x minus x0 into px and x minus x0 whole square into qx both are analytic at a point x equal to x0. That means x minus x0 into px and x minus x0 whole square into qx both has Taylor series at a point x is equal to x0. Or in other words, we are going to use the simple format limit x tends to x0, x minus x0 into px and limit x tends to x0, x minus x0 whole square into qx. Both exist and both has a finite value. Then in that case also this point is called a regular singular point. If either of them is infinite, then in that case it is said to be a irregular singular point. Okay. So please remember, for regular singular we are going to find these two limits If both limit exist and both are finite, then the point x0 is said to be a regular singular point. And for each singular point, you have to do the same process. Okay, you have to do the same process for each singular point. Now, we are going on to the example. Now see, for the differential equation 2x into x minus 2 the whole square y double dash plus 3x y dash plus x minus 2 into y is equal to 0. Discuss about ordinary point, singular point, regular singular point and irregular singular point. So first of all, if you are starting with a solution, then we have to write down this in a standard form. So you have to divide the equation with 2x into x minus 2 the whole square. So you have 3x upon 2x into x minus 2 the whole square y dash plus x minus 2 upon 2x into x minus 2 the whole square y is equal to 0. So if you are writing in the simple form, then what you will have? You have 3 upon 2 into x minus 2 the whole square y dash plus 1 upon 2x into x minus 2y is equal to 0. Correct? So here px is equal to 3 upon 2 into x minus 2 the whole square and qx is equal to 1 upon 2 into x minus 2. Correct? Okay. Now px and qx are not analytic yet. X is equal to 0 and x is equal to 2. Correct? Why? Because this term has a value 0 at x is equal to 2 and this term has a value 0 at x is equal to 0 and 2. Correct? So you have two singular points and therefore x is equal to 0 and 2 are singular points of equation 1. Now for x is equal to 0, so x 0 and 2 are singular points, so all other points, all the points other than 0 and 2, that means if you are taking 1 or you are taking 1.5 or you are taking minus 1, then they all are going to be ordinary. All the points other than 0 and 2. So the set of ordinary points is r minus 0, 2. Okay. Now see what you have to do. You have two singular points. So for x is equal to 0, you have to find out limit x tends to 0 because x0 is 0, x minus 0 into px. That means limit x tends to 0, x into 3 upon 2 into x minus 2 the whole square. And if you are putting the limit, then you will have 0 upon something, that means it has a value 0. So this value is finite. Same manner, you have to find out limit x tends to 0, x minus 0 the whole square into qx. That is nothing but limit x tends to 0, x square into. Now what is your qx? It is 1 upon 2x into x minus 2. So 1 upon 2x into x minus 2. So if you are going to simplify, then you will have x tends to 0, x tends to 0, x upon 2 into x minus 2. So if you are putting 0, then 0 upon minus 4, that will be a 0. So both are finite and therefore x is equal to 0 is a regular singular point. Correct? But now for x is equal to 2. Now for x is equal to 2, you have to find out limit x tends to 2 because x0 is 2. X minus 2 into px, that is limit x tends to 2, x minus 2 into, what is your px? 3 upon 2 into 3 upon 2 into x minus 2 the whole square. So if you are going to simplify, then you will have 3 upon 2 into x minus 2. 1 times x minus 2 will be cut out. And that will give you, if you are going to put the limit, then you will have 3 by 0. That means you have a value infinite. And since this limit is infinite, so your point x is equal to 2 is going to be a irregular singular point. Now, though if you are going to find the limit x tends to 2, x minus x0 whole square into qx, and if this limit is finite, then also this point is going to be, if either of the limit is infinite or both are infinite, in that case this point x is equal to 2 is going to be a, and therefore x is equal to 2 is an irregular singular point. Okay. Same manner you have to do this example. Here you have 2 points x is equal to 0 and 1 are singular points, and for both of them you have to check out whether x equal to 0 is a regular singular or irregular singular. Same manner x is equal to 1 is a regular singular or irregular singular. Okay. So these are the topics which we have covered in today's session. If you have any doubt or any query regarding this topic, then please feel free to contact me. Thank you so much.